One of the biggest problems with our current understanding of the universe is the dark matter problem. By looking at how gravity affects the movement of the galaxies, we think that there's about 5 times more matter than what we can see. But that extra dark matter has never been detected by any experiment on Earth. So it must be made from entirely different stuff than the standard model particles that make us. Now, there are several different ideas about what dark matter might be, and one of the most promising candidates is a type of particle called the axion.
Using a magnetic field, we can turn axions into photons. Within every atom, there is a nucleus, and within that nucleus, there are protons and neutrons. And neutrons are very, very symmetric, and we don't know why. And we haven't known why for a very long time. And the axion is a particle which is naturally able to explain why the neutron is so symmetric. And as soon as the axion was proposed as a solution to this problem, we realized that axions could also be dark matter. And to detect these axions, they interact extremely weakly with everything else. We use a magnetic field, and here you can see one of the miniature magnets that we're planning on using in the experiment here at Manchester. These magnets turn those axions into microwaves, and then by building a series of very sensitive devices, we hope to be able to detect those microwaves and hence discover the axion.
Now, the problem with trying to detect dark matter is that it interacts so weakly with everything else. And in simple terms, that means that it's really, really difficult to see, which is why we call it dark in the first place. So even if we manage to convert axions into microwaves using a really strong magnet, we somehow need to detect this extremely faint microwave signal above all the background noise. And the way that we do that is using something called quantum technology. Quantum technology is any device that uses the laws of quantum physics to do something that ordinary technology can't. And that allows us to solve certain problems. Now, the problem that we've got here is that to detect a faint signal, that signal has to be above the noise of our detector. Now, although that sounds a little bit technical, this actually causes problems for you all the time.
Imagine you want to take a photo in really low lighting. If the photo's too dark, you might try turn the brightness up. But when you do that, you also make all the noisy pixels brighter, making it hard to see what's in your photo. But with certain quantum technologies, you can boost the signal without increasing the noise too much.
And in the case of dark matter detectors, that same idea should allow us to boost the microwave signal produced by axions without contaminating the image with noise. And now researchers at the University of Manchester are building a dark matter detector that works on this principle.
So because the expected dark matter signal is weak, we will need to amplify it so that our detection system can be sure that we found it. For a long time in radio astronomy, we have used transistor-based low noise amplifiers. These use tiny switches to convert the weak input signal into a large output signal. But when they do this, noise arising from the thermal motion of atoms within the transistor is also added to the output signal. Recently, we have started using superconductors to amplify these radio signals. Because these possess almost no resistance, they only add noise arising from quantum mechanics, which is around 10 times lower than amplifiers that use transistors. And this should allow us to detect the axion, which would show just how amazing microwaves are. Not only can they be used for cooking at home, but we can use them to see an invisible part of the universe.